This video is about using the distributive property to factor an expression. This is also known as GCF factoring. So when we factor using the distributive property, we're going to look for the greatest common factor. This is the largest number or variable that comes out of every term. So let's give it a try. So before we start doing anything, we're going to look at a couple examples. So in the first example, we have 12x plus 4. Both numbers are divisible by 4, so our GCF is 4, which goes out front. In the parentheses is anything left over once we divide out that 4. Notice here that 4 was the greatest common factor, so when we divide 4 and 4, we're left with just 1. Then we have 13x cubed plus 7x. Both of them have an x in common, so our GCF is x. That goes on the outside. The remainder goes on the inside. Notice that when we take out an x, our exponents are decreasing. And the last one, 15x cubed plus 10x squared, has a GCF of 5x squared, which means there's a number and a variable as the GCF. Still goes out front, and we divide out what's left. So when you're looking for GCF, you always want to go looking at your number and then look for if there's a variable. Remember that not every variable is going to be a part of your GCF. So just like in the 12x plus 4, 12 had a variable, but 4 didn't, so we wouldn't be including a variable in the GCF in that case. When you are trying to figure out the variable as part of the GCF, we want the one with the lowest exponent. So notice here we had x cubed and x to the first, so our GCF was x. Here the lowest exponent was 2, so our GCF had a 2. So we're trying to find out GCF. A way to help us find GCF is we can either look at it and see, do we notice what number they're both divisible by, or we can write out their prime factors. So when I do that, 4x, two numbers that multiply to 4 are 2 times 2, which are both prime numbers, and we also have an x. Two numbers that multiply to 6 are 2 and 3. Notice that both of them have a 2 in common, which means in this case our GCF would be 2. So for these problems, we're only going to practice finding the GCF right now. In number 2, we have 4g cubed. So again, two numbers that multiply to 4 are 2 and 2. And we have g cubed, which means g times g times g, because remember we'd add all those exponents together. 7g squared. We're not going to worry about the sign for now. That's when we worry about that when we get to the entire GCF factoring. So a number that multiplies to 7 is 7. We're not going to write 1 because we know all numbers have 1 that multiply with them. So we're just going to write 7, and g squared gets us 2g's. So in this case, they both have one set of g's, two sets of g's, so our GCF would be g times g, which is g squared. Number 3, 8y squared and 16y. So two numbers that multiply to 8 are 2 and 4. I'm going to break 4 down, though, into 2 and 2. So I have 3 2's right now, y squared, so I also have 2 y's. 16, two numbers that multiply to 16 are 4 and 4, but we're going to break each of those 4's down into a 2. So I'm going to have 4 2's and 1 y. When I look for my GCF, I notice I have a pair of 2's, pair of 2's, pair of 2's, and a pair of y's. So we're going to multiply that all together to get our GCF. So 2 times 2 times 2 is 8, and they have a y. So our GCF would be 8y. Number 4, we have 11g to the 5th h squared. So a number that multiplies to 11 is 11. And then we have g 5 times, and we have h 2 times. For 19, g to the 4th, h to the 4th, number that multiplies to 19 is 19. G to the 4th, so we're going to have 4 g's, and h to the 4th, so we're going to have 4 h's. So in common, they have a pair of g's 4 times, and they have a pair of 2 h's. So my GCF here then is going to be g to the 4th because there's 4 g's multiplied together, and h squared because there's 2 h's multiplied together. Now in 5 and 6, there's 3 terms. We're going to still do the same thing we were doing. So 12, j to the fourth. Two numbers that multiply to 12 are 2 and 6. But we're going to break 6 down into 2 and 3 because we want to get to our prime factors. And then we have j to the fourth, which means that we're going to have 4 j's. Then we have 15, j to the third. So two numbers that multiply to 15 are 3 and 5. And then we have 3 j's. And we have 9j squared. So we're going to have 3 times 3 times j times j. Now, all of them have a 3 in common, which I notice if I look at the numbers, all of these are divisible by 3. And I have 2 pairs of j's, which again makes sense because the lowest j exponent is 2. So my GCF here then is 3j squared. Number 6, we have 22w squared z to the 7th. So two numbers that multiply to 22 are 11 and 2. Then we have 2 w's and 7 z's. Then for 33, wz to the 5th, two numbers that multiply to 33 are 11 and 3. We have 1 w and then 5 z's. And then we have, lastly, 55z cubed. So two numbers that multiply to 55 are 11 and 5. And then we have 3 z's. So the GCF, they all have 11 in common, which makes sense because all numbers are divisible by 11 in this case. And they have 3 z's in common because the lowest exponent is z cubed. So when I write out my GCF is 11 z cubed because there were 3 z's that were in common. So now let's try factoring using GCF. We're going to do the whole thing. We're going to find the GCF and the remainders. So when we're doing that, we're going to still use the same idea. We can either look at it and see what our GCF is, so what are the numbers divisible by, or we can continue making our list. So if we continue making our list, 9x squared, two numbers that multiply to 9 is 3 and 3, x times x. 15, two numbers that multiply to 15 are 3 and 5. And we have an x there. So they have in common a 3 and an x, which makes sense because both numbers are divisible by 3, and x is the lowest exponent. So our GCF is 3x. Now, to find the remainder, anything that was not circled is a remainder. So with 9x squared, we have a 3 and an x left over, which makes sense because 9 divided by 3 is 3. And if we have x squared and we remove one of them, it's just left with x. The only thing left over from 15 is 5. Notice that your sign that was in the middle between the two terms stays the same. So it was a plus sign before, and it stays a plus sign in our final answer. Number 8, we have 14x to the 4th. Two numbers that multiply to 14 are 7 and 2, and then we have 4 x's. The other term we have is 21x squared. So two numbers that multiply to 21 are 7 and 3. And then we have x times x. So I have a pair of 7s and 2 x's left over, and 2 x's that are pairs. So here for our GCF, we would get 7x squared, which makes sense because both numbers are divisible by 7, and our lowest exponent is x squared. So from the first term then, we have a 2, an x, and an x left over, which would be 2x squared. And from 21, we only have a 3 left over. Now, in number 9 and number 10, we have 3 terms, so we have to make sure that all 3 terms have the same things in common. So 4x cubed, two numbers that multiply to 4 are 2 and 2, and then we have 3 x's. 20x squared, two numbers that multiply to 20 are 2 and 4, or 5 and 4, but we're going to break 4 into 2 and 2, and then we have x squared, so 2 x's. The last term we have is 16x to the 8th. So two numbers that multiply to 16 are 4 and 4, but we're going to break those both down into 2's. So we have 2 times 2 for the first 4, 2 times 2 for the second 4, and we have 8 x's. So all of them in common have a 2, and they have another 2, and they have 2 sets of x's, which makes sense because all of these numbers are divisible by 4, which is 2 times 2, and the lowest exponent is x squared. So the remainder from the 4x cubed is just x. The remainder from the 20x squared is 5, and the remainder from 16x to the 8th is 2 times 2, which is 4, and there are 6 x's left, so x to the 6th. So let's try one more. 8x squared y. Two numbers that multiply to 8 are 2 and 4. Two numbers that multiply to 4 are 2 and 2. So I have 3 2's. I have x times x for x squared, and I have 1y. 10y squared. Two numbers that multiply to 10 are 2 and 5. And then I have y times y. 16, I have x to the 5th y. So two numbers that multiply to 16 we said are 4 and 4, which we can break down to 2 and 2. So I'm going to have 4 2's, 5 x's because it's x to the 5th, and 1 y. So they all have a 2 in common, which makes sense. They're all divisible by 2. We have to be careful with the x's. While 8 and 16 both have x's, the 10 didn't have any x's, so x is not going to be part of the GCF. They do all have a y, so our GCF is going to be 2y. The remainder from the 8 is 2 times 2, which is 4, and 2 x's, so x squared. The remainder from 10y squared is going to be 5y. And the remainder from 16, there's 3 2's, which we multiply to get 8. And all of the x's still remain, so x to the 5th.